Hey guys, welcome to my channel. Today I'm going to talk to you about decorators in Python. First, let me go ahead and show you what you can use decorators for. Logging functionality. Let's say you have a function that runs complex processes and you don't want to be adding print statement all over the function to try and see what it does at any given time. Instead, you want to use a decorator function that does that for you, but not just for one function, but for multiple functions. Okay. Here, for example, we have a function that adds two numbers, but we want to track at what point it's called, at what point it's adding, and at what point it's returning the results. So we pass the function to the decorator function. Here we're passing the name of the function, right? We're adding the numbers, and then we're printing the results, and finally printing the result itself. Okay, so let's run this and see. There you have it. The second thing you can do is access control. Let's say you're running an e-commerce website. You have certain functionalities you want to make available only to those who are authenticated. One way to do that is to use decorators, so you don't have to use control functionality across your code. Just define one function that does it all for you. So decorators can come in handy there too. So here, for instance, we have view profile function that we want to make available to those authenticated. So authenticated flag is set to true here. So our decorator function takes view profile, checks whether authenticated is yes or no. If it's false, if it's true, it will run the function. If it's not true, then it will say unauthorized. Okay. So this small function, you can extend it and apply it to all the functions that you want to restrict in that manner. All right. Third one is data validation. Here I'm using a very simple example. This function is printing numbers, but only if they're not less than 0. So what we're doing here is we're checking the function, we're checking taking the argument, making sure it's greater than 0. If it's greater than 0, we're calling the function and passing the argument. If not, then we're returning invalid number, right? So this is just a simple demonstration of what you can do in terms of data validation using decorators. That means once this is defined, all the other functions you write, all you have to do is just decorate it using @validate decorator, and that's it. It makes your code much more reusable and efficient. Fourth one is performance monitoring. This is much more interesting than the ones we discussed so far. What this does is it times the performance of your function. It starts counting right before your function is called. Function will get called once it's completed, stops counting, and do a simple subtraction and give you the time elapsed for your function to run. So this is another performance monitoring tool or tracking tool that you can use for all your functions and activities you're doing. Again, another way to make your code super compressed and super efficient as well. Here, for example, let me run this and see. I deliberately made this function slow by making it sleep 1 second. So basically took, 37 microseconds, milliseconds, what have you. Another one is caching or memoization. This is a way to make your code extremely fast by storing resource-intensive calculations. Like let's say, for example, here we have a function that does factorials, takes a number, and tries to calculate the factorial of that number. So we're giving, for example, here 5 as an input. So 5, it never calculated factorial of 4, 3, 2, 1, whatever. So it will do the whole shebang and calculate the result of 5. But then when you do the factorial of 6, it starts from 5 because we already know the result of 5. There is no need to start from 1 and 0 and whatnot. So it's just 5 and 6. So here, if I run, you will see calculating the result of 6 took a lot less time than calculating the result of 5 because we had no recollection, we had no memory of anything that's remotely close to 5. So we start from 0. Whereas for 6, we start from 5. And that way we are saving immense amount of resources, especially this scales when you do a lot of complex calculations. Yeah. So if this is something you want to do and implement in your code, just tune in. I will explain the ins and outs of decorators and how you shouldn't be scared of them, because I heard decorators are notoriously confusing for most people. So what are decorators, right? Decorators are higher order functions they take as functions an argument and return a modified version of a function. So in Python, functions are first-class citizens. That means Python lets you pass functions around. You can assign functions as a variable. You can do all sorts of stuff. So decorators are higher order functions because they take functions as an input and produce an output based on the input function. So basically, there are 3 steps that the decorators do: take an input, add some functionality to the input function, and then return a new function that has a modified or added functionality to it. All right. So in order to do this, what should our decorator look like? We have a main function, which we call the decorator function. Let's take, for example, here we have say hi deco. Okay. This is called the decorator function. And then next we have wrapper function, the function inside the decorator adding extra behavior. So the wrapper function is the function that will add an extra behavior to our original function. And then we have our original function, which is here, for example, and any kind of function can be taken as a regular function or original function. And then a return statement, which is the wrapper function, right? So this returns the modified function. So I'm just going to clear this and start from scratch so you guys can see. All right, let's see. Let's define a very simple function. It's a adder function that adds 2 numbers. Very sophisticated, right? Returns, you guessed it, the result of 2 numbers, right? Fancy. All right, adder. Now we pass 2 numbers. 9, perfect, it's working. Now, let's say we want to add some sort of fancy modification to this simple and humble function, right? So all we have to do is define a decorator function. Let's call it adder deco. Okay, it takes a function, func, and then it wraps it. This is where the modification happens. So we say def wrapper takes arguments. So arguments and keyword arguments, quarks, right? And then we modify here, okay? The name of the function, func dunder name, okay? And then we call the function for real. So func takes args, okay? We don't have keyword arguments here, so we just take args. First argument, right? Plus args1, second argument is equal to result. And then we return this modified function. Now, how can we assign adder function to this decorator? Very easy. We just call it temp adder. Not the best variable namer. Call our decorator function, pass in our adder, okay? And then now let's try calling temp adder and then pass arguments like 10 and 3. Comes to mind. Oh, you see? Now it says we are about to call adder, and then 10 plus 3 is 13. So we successfully modified our adder functionality, adder function. We added some printing functionality. We even made it saying, you know, we're about to call and present the result in a much more fashionable manner, right? Now, okay, let's go ahead and apply the usual at decorator style decoration. Let's just clear this for now. Add at, and then the name of our decorator function, adder dec, okay? And now if we call our adder function, what happens? And say 5 and 6. See, because we are about to call adder, we called adder with 5 and 6, and we got result 11. So we've successfully modified it, and all it took was for us to slap this at adder on top of the adder function, and our function got successfully modified. Okay, all right. So just to recap, def adder dec. This part here is called our decorator function. It takes another function, which is adder, as an argument. We're calling it func here, but it literally is adder, right, as a function. And then the wrapper function takes arguments. It can be any kind of arguments, x, y, or it can be a keyword argument, which is if we were given x is equal to 5 and y is equal to 7, those would be keyword arguments. And then we do the modification within this wrapper function, and then the adder decorator returns the modified function, which is the wrapper function. Very, very simple, right? This is what we said earlier. Take a function, add some functionality, and return that function. Now we have adder, right? So let's see if we can see what the name is, right? Oh, it says wrapper, but wrapper is not the name of our function. I thought it's adder. So in order to avoid this issue, we can import wraps from functools, okay? And then here, sorry, not here, above here, we add a little decorator here that says wraps, and then the name of the function func. All right. So we added functools. So now adder. We can even add doc strings here. Okay, let's try to print our doc string. Adder doc. There you go. This function adds two numbers. Amazing. So wrapper function here is literally inheriting the doc string, the name of our original function, and adding much more functionality than the original function. So in a nutshell, this is what decorators are, and this is what they do. Take a function, modify it, and return. But the power of decorator functions shine when it comes to adding logging functionality, as I showed you initially. Like, let's get into the details of these functions. For example, here we've created a log decorator, right? It's taking function arguments here, the same way I've showed you earlier. Here, it's calling the function with args and quarks, and then it's printing with the function name and result, as we've done. So once I have defined this decorator function, every time I call the log decorator on any of my functions, it should show the result. So for example, here, let's go ahead and we have one adder, but let's define log decorator. Let's define a function that prints, says hello. Function says hello called hello. Function hello return none. Why does it return none? Because printing function, it doesn't return anything. Okay, access control. So we have authenticated variable here. Let's set it to false, for example. Okay, and then checks if authenticated is true. If true, we will run our function here. If not true, and we say unauthorized. So this one modifies the access level. It doesn't necessarily add any kind of functionality to how our function runs, but it adds an extra layer of protection for it. See, so it's unauthorized. Validation, we've seen here earlier what it does. If a number is greater than 0, it returns the function. We can add another criteria. If n is equal to 3, for example, we got 3 and number 3. Performance monitoring. Basically what we're doing, as I explained earlier here, we take any kind of function. It's not limited to this function. I can define, I can come and actually what I can do here is add this performance monitoring function here. So you see, you can double decorate if you want. It's called timer decorator. We got 3. It took wrapper. So you see, this is the problem. Because we're not using functools here, instead of saying print number, it says wrapper. So let's even go ahead and modify that. From functools, import wraps, and then we go ahead here at wraps func. Now you see the function name is changed to the original function. It took 0.0012 seconds. See how useful it is? It's created here, but I can go around and apply it anywhere, and it will measure how much time a function took to run, right? So caching, this is another one. Here, I showed you earlier, what it's doing is, but here I'm using wraps, so good. What it's doing is it's caching the result, the returned result of all the calculations I'm doing here. So the next time a similar calculation appears, it will retrieve from the cache instead of doing the calculation. And that saves a ton of time and processing power. And that's all there is to it. There's no magic about decorators. They are just functions that take functions, modify them, and return the modified function. Thanks for watching.